Yeah, so if you got into my session today, I gave you attendance credit. Like I take attendance as I let students into the room. Okay. Yeah, no, I didn't. I haven't really said anything. I was. That's what was taking so long. I was taking attendance as I was letting everybody in. Okay. All right. So, no real announcements. We're just going to keep moving forward with the material as listed in Blackboard. This is the top of week 6, and so we're moving into section. We're continuing chapter 1, moving into section 1.5. We can anticipate exam 2 during week 8, and that's going to be on Pearson, right? Just like exam 1. Okay. Let me go like this. And so again, I'll be monitoring the chat. We can have about 44. We don't have a lot that we have to do. 20. We need to get through about 22 slides. So once we hit about 22, we can stop, and then we'll do the other half on Thursday. But let's at least hit our mark first. I hope everyone's doing well. Let me see. Do I have those options? I do not, but it's okay. Let's see if I do more. Meeting info. That's fine. But yeah. Okay. So let's go ahead and do what we need to do. Again, if you have questions, just type them into the chat, and we'll open it up. I'll be monitoring the chat as we go along. Let me see. I think we're streaming. It should be okay. Yeah, that looks good. Okay. So transformation of functions, right? So I think the last time we did a library of functions, so we had just a list of basic functions that we were, collecting. Basically, we had like the constant function y equals a number, which is a flat horizontal line. The identity function, which is y equals x, which is basically a diagonal line. Then we had the squaring function, y equals x squared, which is a parabola, so on and so on, absolute value, square root function. So now we're going to take those functions and start to do manipulations on them and start practicing some graphing techniques. Yeah, I think I'm going to go ahead and lock the meeting. So hopefully your brothers were able to find this one. I know they might be like, I mean, I kind of let it be. I kind of be chill for now. If I get any kind of craziness, I know what to need to do. Yeah. So if any, if any of your brothers are looking for the room, tell them to just use the link that's in our Blackboard today. I know I didn't post the link because I'm intentionally trying to. It's like, okay, let me go back to my original thing and see how that works, and we'll just kind of. I think the waiting room is fine, but there's still something else I need to do, but that's okay. So now we're going to be looking at manipulations on these basic graphs and start building a case for just transformation of functions, right? So again, it says if a new function is formed by performing certain operations on a given function, then the graph of the new function is called the transformation on the graph of f, right? So let's do it like this. So let f of x be the absolute value of x. G of x is going to be the absolute value of x plus 2. And the h of x is going to be the absolute value of x minus 3. All right, we're actually sketch these graphs on the same coordinate plane. So what we're going to do, we're going to choose like several values of x and then find the corresponding f, g, and h of each, right? So we can see this. Basically, we're going to make a table, right? So we just chose these x values from -5 to 5. The absolute value of -5 is 5. And then for the next part, if we say plus 2, we get 7. So then we did 3. Absolute value of what? 3? -3 is, sorry. Absolute value of -3 is 3, plus 2 is this. And we basically did that all the way down. All right, it's all a repeat, right? So then if we plot the points, we get the two images on the right. The blue is the graph of absolute value of x by itself, right? And then the red is if we add 2 on the outside of the basic function. So we added 2 on the outside. So notice that adding 2 on the outside of our basic function moved it up by 2, right? So if we added 2 on the outside and it moved it up by 2, what do you think happens if we subtract a number on the outside of our basic function? So if adding 2 on the outside moves it up, then subtracting like 3 on the outside, what do you think might happen if you had to guess? You could type it into the chat, right? So if we were to subtract 3 on the outside, we can anticipate the graph to move down, right? The opposite, right? So here it is. We choose several values of x, right? We choose several values of x, find the corresponding y, then we subtract 3, right? So when x is -5, absolute value of -5 is 5, minus 3 is 2. Absolute value of -3 is 3, minus 3 is 0, so on and so on, all right? If we plot these, again, the blue is the original, the red is the new. Notice the graph did indeed move down by a factor of 3, okay? So then, if our c is positive, if we take our basic function plus that positive number, it's gonna shift the basic function c units up, all right? If we say our basic function minus that positive number, it's gonna shift our basic function c units down, right? So outside manipulations are typically vertical manipulations. They're gonna affect the graph in a vertical sense. And it follows our intuition. We added c, it went up. We subtract a positive, it went down, all right? So now let's look at this one. So now let's let the basic function be x squared. And then we're going to do a -2 on the inside and a +3 on the inside. All right. Notice again, these manipulations are inside our basic function. So if outside manipulations cause a vertical change, what can you anticipate an inside manipulation might cause? If outside causes vertical, what do you think the inside causes? So inside manipulation is going to cause a horizontal change. All right. So instead of going up and down, it's going to be something that's going side to side. Okay. So we chose values of x. We plugged it into our basic function. And then the first one, we did a -2 inside the basic function. So then instead of doing -4 squared, we did -6 squared to give us this. This one we did -5 squared to give us this, so on and so on and so on, right? So notice subtracting 2, now I want you to think about the graph, right? The basic function here is going to be a parabola. Which way, now it should be clear that this is going to cause a horizontal change. I want you to think about, okay, which way do you think it might move? If we say x -2, right? Your intuition should tell you that something, right? So just try to think, do you think it's going to move to the left or is it going to move to the right? If we said x -2, right? And then for the next one, we're going to do x +3 on the inside. Think about which way do you think that one's going to move. What does your intuition tell you, right? Okay, let's see what happens. So your intuition may have said, oh, if we subtract the 2 inside the basic function, it should have gone to the left by 2. Actually, it's the reverse, right? Horizontal is typically the reverse of our intuition. So we subtracted a positive on the inside, it moved it to the right by 2. So guys, let's try to use our names as listed in on the roster. All right. So I'm not gonna worry about it for right now. But yeah, if we subtract the positive on the inside, it actually went to the right by 2, which is the reverse of what our intuition might tell us, right? So even though the positive direction is to the right, when we subtract the positive on the inside, it went to the right by a factor of 2. When we added a positive on the inside, it went to the left by a factor of 3 in this case. Okay. So again, inside manipulations are typically horizontal and might be the reverse of our intuition. So all three functions are squaring functions. G is obtained by replacing x with x minus 2. So it says the x-intercept of f is 0, the x-intercept of g is 2. So for each point x, y on the graph of f, there will be a corresponding point x plus 2 on the graph of g. The graph of g is the graph of f shifted 2 units to the right, right? So again, this minus 2 caused it to shift to the right by a factor of 2. And again, this plus 3 caused the graph to shift to the left by 3, which is the reverse of our intuition. Okay. So again, so to recap, if we have a positive c, if we subtract a positive inside our basic function, that's going to move it c units to the right. If we add a positive on the inside, it's going to move the function c units to the left. I'm coming, guys. Okay. All right, let's keep it moving. Let me see. So we're actually doing pretty good. 315. Yeah, we're actually doing really well. I guess it's okay if we get ahead. Okay. So then we have this example where x has sketched the graph of this function. Okay. So the basic function here, I'm just going to use transformations. The basic function here, can anybody identify the basic function? It's similar to the one that we talked about last week. So the basic function here is going to be the square root of x. Let me see something. All right. So what the basic function here is just going to be basically the top half of a sideways parabola, but then we have two transformations we need to account for. First, if we look at this plus 2 on the inside, that's going to move it left by 2 and then down by 3. Right? So we can anticipate something like if this is the xy plane, say this is our graph, right? Then we can anticipate this graph. We said it should go left by 2 and down by 3. We should get a final graph something similar to this. So you see here, right? 2 units to the left, 3 units down. So the book articulates it a little bit different than I do, but we still get the same result, right? Which is the main thing here. Okay, I'm going to let that be. Okay, so we essentially hit our mark. What's the time? I guess we could keep going. So reflections on the x-axis, right? So it says the graph of y equals negative f of x is a reflection of the graph of y equals f of x in the x-axis. If a point x comma y is on the graph of f, then the point x comma negative y is on the graph of y equals negative f of x. Let me see. So if we're flipping about the x-axis, that means our x values are staying the same, and the y's are basically going from positive to negative y, right? So that means the negative is on the outside. Right? Okay, let's see it in action. Right? So if we have our function, whatever the function is, If we multiply the outside of our function by a negative, it's like the x's are staying the same, but the y values are going from positive y to negative y. So if we flip over the x-axis, then we get a reflection like this, right? So that's if we multiply the outside of our function by a negative, it flips it top to bottom, flips it over the x-axis. It's a similar notion for the y-axis. Instead of multiplying the outside by a negative, if we multiply the inside of our basic function by a negative, then it flips over the y-axis. Right? So if we have our function, we multiply the inside by a negative, it flips horizontally over the y-axis. Okay, I think I might make this one the last one for the day. Okay, that's fine. Okay, explain how the graph of this can be obtained from the graph of the absolute value of x, right? So the basic function is absolute value. We have 1, 2, 3 transformations at play here. Okay. So if we start with the absolute value of x, this says go to the right by 2. We multiply the outside by negative, so flip vertically over the x-axis, and then move it up by 3. All right? So we said right 2, flip top to bottom, and then go up 3, and that'll be our final graph. So we start with the absolute value. We moved it right by 2. Then we're going to flip it top to bottom. And then finally, we're going to take that purple image and move it up by a factor of 3. Okay, and that's our final graph. Okay. So here, let's do this. Let me mark this. And let's use this color. Here's what, Tuesday? $22nd. So then I'm going to say start here, Thursday, September 24th. This is the, okay. So it looks like we have about 20 minutes. So what I'm going to do for the rest of class, I'm just going to be available for questions. You don't have to say if you checked in, like if you got attendance if you got attendance credit for today, then whatever you feel like you need to do is fine. I'll just kind of be online and on the call for about maybe 10 or 15 more minutes. So if you have a question with anything, like if you want to help with the homework or anything like that, you can just ask. Otherwise, you know, let's just try to hang out for like 15 minutes, right? And so this is a good time to just kind of work on your homework and ask questions if you have questions. Let me go ahead and share a copy of this so you can access it from our Moodle, from our Blackboard page. I want to send it to Box. This one, this one, this one, the notes, week 6. Yeah, this is good. Like that. Okay. So I'm just nearby. You can here. I'll make it so that you can unmute yourself and just ask questions if you have questions. Okay, that's better. Yeah, if you got into the call, that means you got attendance credit. All right. So I took attendance as I let everybody in. Hey Siri, set a timer for 10 minutes.
Your timer is set for 10 minutes.
We're just kind of getting started. Okay, guys. So yeah, I'm just nearby. Just feel free to unmute yourself if you have questions. Okay. Okay. So if there aren't any burning questions, I'm actually just gonna let you guys go, and we'll continue on Thursday with the next part. Okay, guys. I'll see you next time. Take care.